Okay. Video submission for MEC 140 Lab 5. User inputs, outputs, and interrupts. Part of what we were tasked with was to have a user input cause a digital output to trigger something on a relay to then have a function. And we wanted to have a user interrupt to stop the sequence in its tracks. So right now, basically, this is my relay here. My normally closed terminal is lighting the red indicator light. That means we're at stop. When I press the button, it will send voltage through. Well, the button press will be read as a signal, which will result in an output that will send voltage to the coil, creating an inductance field that closes the normally open terminal, which will illuminate the green indicator light, which means go, and it will start spinning the motor. So let's go ahead and see if that works. Oh, you got to get it just right. Boom. Okay, and if you don't move your finger fast enough, it turns itself off again. There you go. So there we go. It turns it on, and a second button press turns it off. But what we see here is there is a little bit of a delay in the coming and going. Well, that's not great if, oh no, somebody's approaching the spinning blades. Quick, stop it now. Oh, that was close. That was a close one. So what we've done here is we created a user input that we wired into pin 2, and we programmed an interrupt function. And the interrupt function is a special function because it jumps the line. When its conditions are satisfied, it jumps the line of the Arduino's code reading, and it just, boom, activates right then and there. So in our case, it turns off our system. The way we accomplish this over here, take a look at the Cody code, is we got all our variables and stuff up top. You know, we got all our pins, we got our button press count, we got our button state variable, all these things. So the first thing I'm going to circle back to the function because it'll make a little more sense after I kind of explain what happens here. So our void setup, we let our system know that we have an interrupt function that I'll go over here. We let it know that that's the case. We let it know that the pin labeled interrupt at pin 2 is going to be functioning as an interrupt. That's what this, I believe, is what this means. Oh no, the lights turned off. Isn't that great? Jump up and down. There they go. They turn on. Yay. All right. I've been sitting here for a while. Anyway. And then our relay is an output, and our start button is an input, and our refresh, whatever, set to 9600. Then our loop of our code is we want the state of the start button to be checked. So we digital read the start button, and basically that will read if that pin 11 is high voltage. And a little delay there because sometimes if you don't have a delay and you press the button, it'll, if you get it at the wrong part of its its refresh, like it basically will turn itself on and off before you can move your finger. So you put a little delay in there so you can move your fat fingers. I still managed to press the button and turn it on and off, but anyway. But anyway, if the voltage on that pin is high because the button's pressed, we start our button count. And when our button count is 1, we turn the output pin high which then, in our case, closes the normally the normally open terminal, and then that receives its own power supply from the 3 volt or the 3.3 volt, which then powers this motor and LED. And then when we press it again and the button count is greater than or equal to 2, we turn the relay low, and that opens the normally open circuit and closes the normally closed, which illuminates our red indicator light. We didn't necessarily need that. We could have had nothing there, but I just, I was like, hey, I got the relay, I got both sides, I'm going to wire them both. And this is an important one, and it resets the counter back to 0, the button count back to 0, so that we can just do it again and again and again. We can keep going through. Now, our interrupt sequence here, we put that function up here before the setup. And basically the way it works is, we check the state of the interrupt button by reading the voltage at the terminal 2, at pin 2. And if it's high, we restart the button count to its default off position, for the off position for our system. So that's how it works. I tried a couple things. I tried digital write, make the relay low. That didn't work. A bunch of things didn't work, and I was like, well, why don't I just make the count the default where everything's off, or where the system's off? And that seemed to work. So that's what we did. And like I say, part of what you saw is it's just a little faster turning the system off than waiting for the button. And we don't have a very complex code here. There's not a lot of timing. There's not a lot of anything. So it doesn't make that much difference in this context. But say we had a dozen functions to go through, or if the button press, our start button press did a sequence of 4 or 5 things that were all timed out, and you had to wait till it went through its sequence to then interface with the button to make it stop, the interrupt would bypass all that, and you could tell it to do whatever. In our case, just turn off the system. So that is basically it for interrupts. Yeah, it was a bear, but we got her done. Alrighty, we'll see ya.